Hello, this is the Basic Python seminar again, and this is the ninth session, which is about dealing with files, specifically reading from files and writing into files. Okay, so far, when we wanted to make our programs interactive, we were always gathering input from the user of the program using the built-in function input, and we were supplying output to the user using the built-in function print. This works very well, but at a certain point, it starts to become boring, and it's also limited in the way which kind of information can be inserted into the program and gotten out of the program. So today we will deal with reading information from files and also writing information back into files. And this obviously allows for more opportunities for your program, since you can like get and return larger amounts of data. Obviously, there are different file formats. If you're working with Microsoft Office, there's, for example, doc and docx for text documents, and there's XLS and XLSX for table sheets. Then there's image formats such as JPEG and GIF. There are exe files, which stands for executable. And then there are .txt files, that is plain text files, which only contain the characters which were inserted into them. And nothing else, so no formatting specifics, which you typically have in Microsoft Office documents. We will start dealing with text files, but before we do that, I want you to download an archive called data.zip. You can download this here from the course page, data files for the course. It's also available here for session 9. And if you don't have access to this course page, you can go to the online course notes, click section setup, and then this links to intro proc examples. And this zip file contains the entire material for this course, including a subfolder data, which will be of interest to us now. So I have placed this in the directory in which I will be coding today, and I have unpacked it. This gives me a subfolder data, and in this subfolder, I will first open the file melville moby_dick.txt. So if I open this file, it looks like this. You can also open this in another editor to reinforce the point that it really only contains the letters that have been inserted into this text file. So it's a plain text file. And it contains the entire text of the book Moby Dick, written by Herman Melville in 1851. And as we know that our editor in Spider is also a plain text editor with some code coloring features, of course, we can also open this in the Spider editor if we want. And I will actually leave this open here so that we can check whether we are actually reading from this file while we're doing this. So if I want to read from this file, I first have to specify the file path. And for that, if you remember last session, I need to import the OS module for interacting with the operating system. And then I can simply specify the file path as a folder, as being located in the folder data and being named like this. So let's see what we get. Yes, this is a relative file path to this text file, which works if I am located, if my current working directory is the folder which contains folder data. So for opening files, there's a built-in function which is called open. So we can simply call it open file path and then submit the result of this operation to a variable called f. So if you get the error, no such file or directory, please check a few things. Check whether you have actually downloaded the file, whether the file name is correct, whether the file is actually located in the subdirectory data, and whether you are in the current working directory. You can in Spider here check using by having a look at the path bar or by typing the command get current working directory. So in my case, the file name was incorrect. So as you can see, I have spelled Moby Dick incorrectly. So I will call this command again. And then open the file one more time. So if you were expecting the type of this, of the result of the open function to now be text or string, for example, I have to disappoint you because type of this variable is underscore io dot text oi wrapper. On some operating systems, this may just be called text io wrapper. And IO here stands for input output. So in coding or programming, IO often refers to input output. And you have to, you should see this variable f as just a generic object for communicating with the file. So I will refer to this as a file object in the remainder of this session. Okay, so how do we find out what we can do with this file object? Well, we of course call the dir function with f as an input. This gives us a list of methods which are applicable to this file object. Once again, there are a lot of methods starting with double underscore. We can ignore this for the moment, but we see things such as read and write. This sounds very good. So let's just try to use read and write the command text equal to f.read without any input. Okay, so we're trying this command. And once again, we're asking for the type. What will the output of the function reading from a file be? And this time it is a string. So now we have not just opened the file, but actually read information from the file. We can have a look at the text of the file by, for example, printing the first 1,000 characters. And if you compare this to the left here, you can see that it's exactly the same text as the one that is in the text file. It also includes new line characters. So whenever there is a \n in the string, then which is of course here not visible because it's not printable character, then the file jumps to a new line, and the same happens here in the output. If you're wondering how many characters are in this file, you can add text, and it says that there are 1,220,065 characters in the file in total. Okay, so with the text of the file being a string, we can also perform string operations on it. So we can, for example, define a target word And then how often this target word occurs in the text. So if you don't know it, Moby Dick is a novel about whales, uh, specifically one whale, and therefore there's a lot of talk about whales in the novel, and the word whale occurs in this form 1,322 times. Uh, However, the word whale may also occur in uppercase letters, as we see here. So in that case, we have to lowercase all the letters in text first and then count the occurrences of whale. So in this way, we find out that the word whale, regardless of lowercase or uppercase letters, occurs 1,685 times in total. Observe how I was here chaining the methods. So I was first applying the lower method to the text string object. And then to the result of this, I was applying the count operation. There's also a similar way of chaining operations when reading from a text file. So remember that before I was using open to read from the file and then f.read for reading the actual text from the file. We can obviously combine these two commands and get the text from a file in just one line by writing this. This is very practical because you can then use this just this single line for printing out the entire text from a file, which has been specified via its file path. I will not do this right now because this is a very long text file and I don't want to cram my console. Okay, so now I want to open Find Word version 1. And briefly have a look at this program. So what am I doing here? First, I'm opening and reading the file as we have already done. And then I'm using the string method split lines to cut the text into individual lines. So remember that right now it's a single string composed of this 1 million characters. And I want to have the text as separate lines of the file. So split lines creates a list, and each entry of the list will be a string, which is the next and the next and the next line in the file. And then as lists are iterable, I'm running a for loop across this list. And as soon as the target word occurs in the lowercase version of the line text, file line text, I'm breaking from the loop and reporting this line. So I'm running the script. And I get the following output. The first line containing whale is name a whalefish to be called in our tongue, leaving out, and so on. Okay, so once again, this was using split lines to create a list from the text file containing the lines of the file as individual strings. It turns out that not just lists, but file objects themselves are iterable, and one can make use of this for reading the file line by line. So for that, I'm opening Find Word version 2. And you can see that up to circa this point, it is exactly the same. So we're opening a file for reading. And then our for loop does not iterate through the list of lines from the file, but it iterates through the file object. And we're saying for each line in the file f, if the target word occurs in the lowercase version of this line, then break from the loop and also report this line. So let's run this program and we see that we get exactly the same output. So to sum up, there's two ways of reading a file line by line. The first one is reading the file entirely and then using split lines to come up with this list of lines, which is very advantageous if it's a small file, like the text file we are here looking at. It's just 1 MB or so. Or you can first just open the file, which, as we know, doesn't immediately give you the text contents of the file, but only a file object. And then iterating through this file object will read this word line by line. This can be advantageous if you, for example, have a very, very large file which you don't want to read uh, at once, but only need to read until you reach a certain point. Okay, so this was it on reading plain text files. Next, we want to deal with writing into text files. And we already saw that there was a method um, of f being called write. So let's just write into the text file. And as an input to the write function and given the string, can you write into existing files? And what I get in return is this unsupported operation not writable. And this is because I haven't opened the file for writing. The file has only been opened for reading. This depends on the way in which you're calling the the open function from Python. So I'm now specifying a new file name because I also don't want to overwrite the contents of the book Moby Dick, which is the file path which we were previously using. So I'm specifying a new file path, my new file.txt. And this time I'm again calling open, but use the mode argument of the mode keyword argument of the function. And I'm going to set it to W. So in return, we will also get a file object, F, but now this file object or this file has been opened with the permission of writing into the file. So as you can see here, it has already been created. Let's call fwrite again. Writing your first text file is exciting. So if we now switch back to an Explorer and try to open this file, we see that it is still empty. So our file has still no contents, although we have just written into the file. Why is this? Well, this is because the changes that you're making to the file may not come into effect until you actually close the file. You can see this a bit like saving when you're writing files in the text editor or Notepad. So the method for closing a file is close. And obviously it also doesn't need input arguments because there's nothing that we need to specify if we want to just close the file. Typing this and have a look at the file one more time. And now our text is there. Perfect. Writing your text file, your first text file is exciting. Good. Then there might be, so let's see what happens if we are writing into the text file again. So I'm opening the file path again for writing. Tab writing your second text file is less exciting. And I'm closing the file. So if I now reopen the file, might not be what you would have expected because we've just overwritten the entire contents of the file. And the sentence that we were first writing into the file is not there anymore. So if we, so if you are opening a file using the keyword mode argument set to W, this always means create this file, empty it completely, and start from scratch. So you're writing into an entirely new file. Now, this can mean that if this file already exists, it's being emptied and overwritten. If you want to prevent this, you have to use, when opening the file, the keyword argument mode set to a different value. So if you're setting this to X, this means something like open the file for writing, but if the file already exists, give me an error. And this is exactly what happens here. The program aborts or command doesn't work because the file already exists. Now, it can be that we want to write into an existing file, but we don't want to erase all the contents which are already there. In this case, call open with the keyword argument mode set to A. A here stands for append, which simply means adding to the file. So if we now try pending writing again, pending to the text file is boring, and we close the file. Let's have a look into the file again. So now this is exactly what has happened. We've added the second sentence to the file, but as you can see, the writing text into file action has really done nothing more. It has not introduced a new line. It has not introduced a space or something. So we are really writing exactly to the end of the file. So if you want to prevent such ugly formatting errors, you would have to put, you would have to use escape characters, for example, which are most often starting with backslash. For example, \n stands for here, insert a new line. And then we can write in this way, it looks more aesthetic. Writing this and close the file again. So with that, our file looks like this afterwards. Okay, very nice. So here's another example reinforcing the use of escape characters for shopping file. So in the top of the script, I am defining the well-known shopping list, which we were already working with a couple of times. And I want to write this shopping list into a file called shoppingfile.txt. So I'm opening this file, but I want to write this information in a specific way, namely as an enumeration. So I'm using enumerate with the shopping list as an input, which, if you recall, gives us a list of pairs where each pair consists of the index of the element in the list and the element itself. And then we write into the file a string which contains two placeholders. Curly brackets indicate placeholders, and these placeholders are filled then with the index plus one, because Python starts counting at 0 and humans usually start counting at 1, and the item itself, which is just a string. So this is written into the file is closed, and then we print the entire contents of the file. So this is what is done using this last line here. So let's see what we get. Sorry, I've accidentally written a character into the file. Okay, so this does not look very nice, precisely because we have not used escape characters. So first, we have to introduce a new line character here, such that each item is on a new line. And if we do this, then the text file looks like this. There are other escape characters. For example, you can use \t, where T stands for tabulator. So there's always a specific amount of spaces between, in this case, the index and the shopping item. So this would give us the following output, such that all shopping items are aligned with each other and the numbers are also aligned. So here's another demo, which is circumventing the use of new line characters by defining a multi-line string. Okay, so once again, we here have the shopping list. And then what we want to write into the file this time is called a shopping summary. And this is a multi-line string, which I indicate by typing 3 double quotation marks. So when there's a triple quotation mark that says, I'm now starting a string, please store the string, even if I go to new lines, as long as you see the next 3 triple quotation marks. So this string is defined to run from here until here. And we're using line breaks in the string. So using this triple quotation mark notation, we can define multi-line strings. And then the strings have placeholders again, which are supposed to be filled with information. So we're opening the file shopping summary, we open it for writing, and then we write into the file the shopping summary, and we're filling the placeholders with the length of the list, so the number of items, the first item in the list, so the first shopping item, and the last item in the list, the last shopping item. Close the file and read the entire file contents. I'm running the script. And I get the following output. So this is another way of working with multi-line or with adding new lines into the text file by defining multi-line strings. However, remember that this is only possible if you can, if you know beforehand how many lines your file or your string is containing, which may not be the case if you are writing data sets into the file line by line and you don't know when you're starting how many data sets that will be. Okay, so now I'm defining a new file name, which is called my next file. And I'm using our well-known notation for opening this file. Write permission. I'm sorry. Change variable name here. Okay, so if you have done this, try typing f.closed. So closed is an attribute of the file object telling you whether the file is still open or whether it has been closed. So since we have just opened this file and not yet used close, the file object method, the file is still open, so closed is false. If we now type f.close, then the file is closed, which means that f.closed must be true. So this is a Boolean attribute of the file object telling you whether the file is still open or whether it has been closed, in which case it is true. Okay, it is always good practice to close the file after writing into the file, but this may not happen if your program aborts at some point. And here's an example showing this. So at the beginning of the script, we are defining some variable, which in this case is a number. So I'm emphasizing already that this is not a string. And then we want to write into a text file. We open this for writing, and we use the write method to write this number into the text file. I'm running the script, and it doesn't work. It says write argument must be string, not int. So the method write for file objects definitely needs a string as an input. Yeah? This is because files also can contain other things than just numbers. They can contain all sorts of characters. And therefore, whenever you're writing in the text file, the input has to be a string. Okay, now, but the more important point is that the program has aborted here at line 11. So everything that comes afterwards supposedly was not run. Let's check this by asking whether the file is closed. And this is indeed false, because the file has not been closed. Now, how can we avoid this, our files being still open, although good practice is always to close files, if we run into an error message? Well, for this, we need context managers, and here's how context managers work. Let me first store this under another name. Okay, so the idea is as follows. we take this file object, write with open file name as f colon new line indentation. This is an ordinary control statement. And then write the number into the file. Okay, here's the general syntax of context managers. With some variable as name, colon, and then a new line indentation and some commands involving the name. Okay, and what that means is something like the following. Take this variable, whatever it is, can also be a function call, as in our case, which returns the variable. Take this variable under this name and do with this variable under this name whatever has been specified here using this name, and then clean up regardless of whether there was an error message or not. Now, what does clean up mean? Well, clean up can mean different things for different data types, but here we are working with files. So cleaning up for a file probably means something like close this file, regardless of whether there has been an error message or not. Okay, so let's try to run it. Obviously, we get the same error because the command on line 11 is still erroneous. It still doesn't work. We cannot write integers into files. We can only write strings into files. But if I'm now asking whether the file is closed, I get a true. Even though there was an error in me working with the file has been closed due to the use of context managers. Yeah. So the context manager with open file name as f means whatever you're doing in the following, make sure to clean up. And cleaning up in this case means closing the file because we're working with files in this case. Okay, so the correct solution here obviously would be to convert the number to string for writing. And in this case, we don't get the error message, and the program has worked, and our file has been closed. Even though there's no explicit command in these lines to close the file, our file has been closed due to the use of context managers. Okay, so with that, we want to leave text files behind and get to another format of files if you want, which is delimited text. Here's an example for delimited text. So I'm working with the file penguins.csv in the data folder, and I'm opening the script read penguins. And if I run the script, this simply prints me the first 6 lines from the script. Sorry, from the file. And the first 6 lines are these. So it looks like some information arranged in a tabular way. So there's different pieces of information for each observation, and the pieces of information are named. So there are column titles, bird, heart rate, depth, and duration. And the different pieces of information are separated with commas in this case. So the I was saying that this is delimited text. So the delimiter in this case is comma, and it indicates that whenever there's a comma, go to the next column, or this is to be understood as referring to the next column. So this file format is called CSV, or comma separated values. A CSV file is, in a sense, a plain text file because it really only contains the this text, as we have seen by printing out the first few lines. But it has some structured information in it. So when you're reading CSV files in Python, you shouldn't read them in the way as I was doing here, because this will not allow you to get the structure out from the file. Instead, you should use pandas for this case. Before I do this, I want to show you that CSV files can come in different forms. So this would be a German version of the CSV file. Sorry, let me rather show this in this way so that I have both on the screen. So as I told you, the comma here was used as a delimiter, but in German, we unfortunately use the comma as the decimal separator. So here, instead of delimiting columns with commas, the semicolon was used. So that, strictly speaking, this is not a comma separated file, a comma separated values file, but it's a semicolon separated values file. Pandas can take care of this, and we will see in a moment how. So first, to start working with pandas, we need to import it. And for that, we simply type import pandas. Pandas is not a part of the standard library, and still you can import it when working within Anaconda or Spider, which comes with Anaconda, because it's a rather popular package. So it's a third-party package, but it's very popular. Therefore, it has already been supplied with the Anaconda distribution. And now we can type pandas.read CSV. And as an input argument, we need to give it the file path. So first creating the file path. And then call the function read CSV from the pandas package. And I'm going to write the output of this into a variable called penguins. Okay, if you ask yourself what this is now, this is a pandas data frame. Data frame in this case means that it allows to organize tabular data, in which case all the rows represent observations and all the columns represent quantities measured for these observations. So we can have a look at the data frame by printing penguins, and this then looks like this. So it prints the data frame in a user-friendly way where it only shows the first couple of rows and the last couple of rows. in order not to cram the console, but it shows us the entire amount of data contained in the data frame, which in this case is 125 rows. And as we can see, this does not show the file as a plain text file, but it shows the tabular structure of the data. Pandas can also take care of CSV files which do not use the standard notation, that is a point as a decimal separator and a comma as a delimiter, as was the case in the German penguins file. So if you want to take care of this, you have to use the keyword arguments of read CSV. Before that, let me change the file path. And now I'm using the keyword argument sep, which specifies the separator between the columns. And I'm using the keyword argument decimal, which specifies the character used for decimal notation. And we have seen that in the German penguins file, these were semicolon and comma. So with that, we get the same information as before out of the text file. Okay, so this is it for CSV files. At the moment, we will return to this file format and also pandas data frames in a later session when we work on data analysis and data visualization. But for now, I want to have a brief look at the last file format, which is the following. So in the data subfolder, there's a file guardian taramasalata.json, and I'm reading this file using the following script. So I'm once again printing out the first few lines from the script and from this file, I'm sorry. And we see a few things. It looks very incomprehensible. It looks as if there is some structured hierarchical information inside the file, but in this way we can obviously not really make sense from it. So as for CSV files, for JSON files, it's the same here. Please don't read them in this way as plain text files, but rather use dedicated packages and modules for interacting with JSON files. So JSON is also pronounced JSON, and it stands for JavaScript Object Notation. JavaScript is a programming language, and it also has some formal notation for specifying ontologies and objects and their attributes, and properties, objects being like the children of other objects and things like that. And this is all realized in the JavaScript object notation. So the Python module for reading JSON files is surprise, called JSON. So we can simply type import JSON, and this allows us to work with JSON files. The function for reading JSON files in the JSON pocket is called load, but unfortunately it does not accept file names like the read CSV function from pandas, but it accepts file objects. So there's always a few inconsistencies between the different Python packages. Let me first specify the file name, and then I show you how it works. So we're calling JSON load. So here, unfortunately, the functions are not called read and write, but load and dump for whatever reason. So we open the file path for reading. Remember that if we're not using the mode keyword, the default value of this is R, which stands for reading, and we're writing the result of this operation into a variable called guardian. Okay. Once again, we're asking what type this data is, what data type it belongs to, and it tells us that this is a dictionary, which makes sense because the file here is starting with some curly bracket, and then there's an entry or key, and then there's a curly bracket again. So this is very similar to Python's notation for dictionaries, which also uses curly bracket for indicating that a dictionary is being specified, and then within the dictionary there are key value pairs. So with this being a dictionary, we can obviously ask what the keys in this dictionary are. And there's just one key in here, which is response. So let's ask for the value behind this label. And we get a lot of things. So we ask for what type this is again. Again, a dictionary. So let's store this under a different name and ask for the keys again. There's a very long list of keys. We're going to focus on results. And we get a lot of things again. So we're going to ask what type response results is. It's a list. So we're writing this into a different variable name and then have a look at the first element from this list. This is a lot of things again. So we ask for what the first element, what type the first element from this list is. It's a dictionary again. So we can ask for keys of this dictionary again. And there's, for example, the key web URL, which is an actual URL. So when importing a web browser, it should be possible to open this URL. And this is true. So it's apparently an article from the Guardian entitled "An Alternative Use for Scallop Roe." Seems to be a cooking recipe. And it contains the word Tara Masalata. And this is why the JSON file, which we were here using as an example, is the list was some collection of articles from the website theguardian.com containing the word Tara Masalata. Okay, so to sum this up, what do we learn from this? We learn that information which you're scraping from the internet often comes in this very complicated hierarchical structure. So complex nested structures like the one which we saw here are very common for data which are somehow scraped from the internet or gotten as a result from an API which you use to communicate with the website. So as a last example for today, I want to show how to write into JSON files. So I'm here defining a dictionary. The dictionary has three key value pairs. The labels are shopping, chores, and reading, and each value is a list of things that are to be done. And I want to write this into a file called to-do-file.json. So I'm importing the JSON module again. And then I have to use the function dump, which here means the same as write. And this function takes as an input the dictionary, which is to be written into a JSON file. And once again, the file object of the file, which is created using the open function. So if I run the script, I get the following output. I get exactly this dictionary written into a text file. But though it's, of course, machine readable, it's not very easily human readable. And this can be made a bit better by using the indent parameter of the dump function from the JSON module. And this causes some indentation when writing the JSON file, such that it's more easily human readable and the hierarchical structure of the dataset also becomes apparent. So this was it about JSON files, and this was it for today. If you have a look at the exercise from today's session or from the online lecture notes, please, before you do this exercise, have a look at the section encodings from today's lecture note. Again, so in the lecture, I was skipping over this because it would have consumed too much time. It's a little introduction into different ways of encoding the file contents, so converting characters into numbers. There are different standards like the ASCII standard or UTF-8, which derives from Unicode. And the encoding which your system is using by default may depend on your locality settings. And please, before you do exercise 1, read through this section, and then you should be able to do exercise 1. And exercise 2 is once again working with the JSON file that we were also reading in this session. Okay, so thank you for listening. Hope you also enjoy the other videos, and goodbye.